Hey everyone. So I just wanted to take a minute to talk a bit more about interpreting measures of central tendency. Right, so we talked about the three major measures of central tendency: the mean, the median, and the mode. We know that the mean is just an average. The median is the middle number, the 50th percentile, and the mode is the most common number. We talked a bit about how to calculate these. You may also remember that from school, from high school. But the really important thing for our purposes is actually how to interpret them, to know what they mean, right? You can rattle off numbers, but if you don't know what they mean, there's just not a point in learning them for this class. So thought we'd start by looking at some data. This is just data matrices for Republicans and Democrats in the 113th and 114th Congresses who served in the Senate. And you might recall from class that I calculated these climate scores for them, right? It's just a percentage score where it's the number of votes where they voted what I term to be pro-climate divided by the total number of possible climate votes they could have cast. So the data matrix tells us something, but the problem is because I'm doing them as two Congresses clumped together, there's quite a few names, right? More than 100. So even dividing up by Democrat and Republican, there's really a lot of names on these lists. It's just hard to visualize this, to do anything with it. So the first step, and this is the step we took in Monday's class, is, there we go, to make a crosstab or contingency table. Now, we could also use a frequency table if we were visualizing one of the variables, right? In this case, the count of, say, just Democrats or just Republicans. But because this is bivariate data, we've got two variables, Democrat, Republican, and score, right? That means that we need a crosstab, or again, what's called a contingency table sometimes. So for this one, all I've done is a very simple count, and I've changed my interval variable with my score from 0 to 100% into score ranges. So I've changed my interval variable into an ordinal variable. Why did I do that here? Well, honestly, just because if I'd left it as an interval variable, this crosstab would have been 100 rows long. And the whole point of putting things in a crosstab as opposed to my data matrix was to make it easier to read. So 100 lines was not going to be helpful. So you can see I took my, again, my interval and divided it into different discrete chunks that are categorical. So we have this crosstab and contingency table, or contingency table rather, and it tells us something, right? We can start to see, hey, Dems clearly vote in the lower score ranges less, and in the higher score ranges more. Republicans, it's the opposite. Democrats also seem to be way more concentrated at the top, but then have more of a tail, right? They go further across the scale. Republicans seem to be a little bit narrower on where they are on the scale, but at the same time, a bit more spread out, right? So we'll talk about these measures of spread in a minute, but what we're going to look at now is central tendency, and that is pretty hard to do with a contingency table or cross tabulation, because we can see, right, that there's clearly some clumping. For Democrats, it's at the high scores. For Republicans, it's at the low scores. But what exactly does that mean, right? And if we use these measures of central tendency, we can get a better grasp on that. So we have the mean here. That's the average, right? That's sort of colloquially what we call the average. The average score for Democrats is 86.2%. For Republicans, it's 14.2%. If you look at our data, that seems a little weird, right? The data is so concentrated for Democrats in the 90 to 100 range, and for Republicans really in that 0 to 10 range, that it seems a little odd that the mean is outside of those ranges. Less so for the Republicans than for the Democrats. But the reason the mean is dragged away from where we're seeing a lot of our numbers is actually because the mean is very affected by outliers. One extreme value can drag your mean off to the side. And in this case, our extreme value for the Democrats is that score that's somewhere between 10 and 20. And for Republicans, it's the score between 70 and 80. You can see 10 and 20 is further from 90 to 100 than 70 to 80 is from 0 to 10, which is why the Democrats' mean seems to be being dragged further from where that clumping is. To avoid this, we can use what's called the trimmed mean. We can just chop off a percentage of scores on both ends. That usually takes care of our outliers, gets rid of those really extreme values that are just weird. I believe the extreme value for the Democrats is Christian cinema, though I may be wrong about that. I know Senator Manchin, who is the one I would have suspected would be our extreme values, actually in the 40 to 50% range. And for our Democrats, that extremely high value is Susan Collins. So getting rid of them can help us a little, right? It can give us a better idea of sort of the trend, how most Democrats vote, how most Republicans vote. But for this data, something that might be helpful for us is the median, right? That's half of Democrats vote below the median, half of Democrats vote above the median. For Republicans, obviously, it would be half of Republicans vote below the median, half vote above the median. So the median for both of these is towards the extreme, right? It's moving closer to the extreme than the mean is, because the median is less affected by our outliers. It's less sensitive to them, we say. So the median of 94.3% for Democrats suggests that there are definitely some outliers, right? The median is further to the, if we're looking from smallest to largest, right? It's further to the right. We typically start our smallest numbers at the left, right? Because we read from left to right. So it's further to the right. It's further to the extreme. And the extreme, in this case, high numbers. So we know that there are probably some outliers, or at least oddly low values in there, but for the most part, the values are pretty high. And we can do the opposite for the Republicans. Now we notice that the median is not as far from the mean and not far at all from the trimmed mean for the Republicans. This shows us that the Republicans seem to be a little more clumped, right? The Democrats seem to have more spread. Now, it's kind of funny, right? We can talk about spread from measures of central tendency, but that can help us, right? If we know that the central tendency is something that's kind of helpful to put into context by saying, well, how much isn't around that center, right? Now, our mode is just our most common number, the most frequent vote. And in this case, for Democrats, it's 96. So it's even higher than the median. So we have the mean has been very much pulled by that one extreme value, that one 10 to 20 vote. The trimmed mean was still pulled by lower values, though of course that 10 to 20% vote had been left off, had been trimmed away, but it's still being affected by these lower values. In this case, I knocked off the lowest 3 votes, so it would be being pulled by that 50 to 60. Well, those 2 50 to 60 votes. And then the median is not as affected by this, right? Because a few values on the one side doesn't really affect where our 50th percentile falls. Just pulls it a teeny bit, but not all that much. Now the mode, because it's the most common number, isn't affected at all. Now modes can be problematic when we have a lot of spread, because sometimes we get multiple modes, or sometimes a mode is just like one higher than the next most frequent number. You know, we only have one more vote at 96%, Congress member at 96%, and we did it 95%, but it gives us something. And with this data, it's actually a very helpful tool. Because again, we see that for the Democrats, the mode has moved more to the extreme. But for the Republicans now, the median and the mode are the same. Seems to indicate that our data is very clumped. They are much more gathered around that central measure, the Republicans, whereas Democrats may be strongly, very close to that extreme, right? 96%. And even if you look at the median, 94% is much closer to that extreme value of 100 than 12% is to the extreme value of 0. So we know that Democrats' central tendency is actually more extreme. They are more likely to be at an extreme, but they also have a lot more spread around that, because we see these numbers sort of move along depending on which measure we're using. Whereas the Republicans are actually slightly less to the extreme than the Democrats, but they're very clumped around that low number. So this can tell us, if we're, say, looking at polarization, that in the case of climate votes, maybe our polarization is asymmetrical in that the Democrats are more to the extreme than the Republicans, which bucks usual trends that say the Republicans have moved more to the extreme than the Democrats. However, in sort of standard form, the Democrats have more sort of variety going on. And whereas the Republicans seem to be more clumped around their party average. So we can see that even though the Republicans may not be as extreme, they are sort of more consistent as a party. So that measure of central tendency can hint at consistency. Now, if we really want to look at consistency, if we really want to look at the spread, we should use some measures of dispersion. So I will talk about that in my next video.